Sure. Hey guys, can you hear me?
Now
Okay, great. Hi, my name is John. I started this project for OceanHackWeek 2022 as a continuation of some work I'd done last year at OceanHackWeek 2021. So the point of my project is developing a Python package for Radar Doppler Spectra imaging quality control. So the initial motivation was due to the existence of a file format called cross-spectrum file format, which is a special binary format that's emitted by certain types of antenna that are used commonly in Doppler imaging for estimation of ocean current data. This is not very interoperable. It doesn't offer a lot of features with a lot of conventions that are used, for instance, NetCDF. So I had worked on developing serialization and deserialization routines from this binary file format into a Python object that would expose antenna spectra, range-dependent antenna spectra as NumPy arrays. This year, after learning more about X-array and NetCDF, I decided to extend this by adding X-array interoperability, which ultimately leads to NetCDF interoperability, which is sort of opens the door for a lot of different technologies that are used in oceanography. So I have this README here, which I'll kind of walk through, which is basic documentation for this Python project. The gist is that there's a load method. So if you've ever used Python JSON module, or you know that there's a load and a dump method, which is sort of a very common pattern as an entry point into serialization functionality in Python. So you can load these file formats, these files into Python object, and then you can apply pre-processing filters on them. So a common thing in quality control is data being flagged as an outlier. So in this particular file format, data is flagged as an outlier by being negative, because all the data is guaranteed to be positive because it's stored as volts squared, because it's pulled off a sensor squared, and then the negative values are used to denote outliers. So negative values can be ignored via taking the absolute value, or they can be rectified by canceling them out. So that's, and this interface, processing interface, is extensible. So it allows users to extend this and to treat outliers differently depending on what they want to do. So the next thing, which is really what I worked on this year, was adding a toXarray method to my CS file object, CS file meaning cross spectra file. So toXarray basically encodes a lot of the metadata of the frequency that is being scanned over, as well as the range that this is being scanned over as X-array coordinates. And it allows you to work with the data a lot more easily and to have to basically do nothing if you want to plot it or if you want to do any sort of data analysis. So this is a little example that I put together that sort of shows how easy it is to load something from a cross spectra file with a load method, convert it to an X-array data set object. You can print it, which is just, sort of a sanity check, but then you can plot it, which is the result of this plot down here, which is, if you see on the left, it sort of has all the X-array features, which are the labeled coordinates. You have your units, as well as on the bottom, you have your labeled coordinates and units, which I tried my best to match CF standards. So radiation frequency is a CF standard. There is no CF standard for range. This is something, I'd be interested in exploring. And then additionally, I designed it in such a way where you can, the X-array object is easily convertible to NetCDF. Not all X-array data is, but I designed it so that it would be. And so you basically have full interoperability between cross-spectra data files, which come right off of the antenna, into NetCDF, which can be used in databases, or really how any researchers want to use it. Some future work, which sort of, it has to do with the fact that there's only a few days to work on this, really. Something that is sort of inherent to spectral data is complex numbers. Something I didn't know and found out is that NetCDF does not offer support for complex numbers. This is, I mean, spectral data may be on the fringe of things that are commonly used in NetCDF, so this makes sense. A lot of it's just regular time series, but spectral data has amplitude and phase information usually encoded in it, and so it needs to be complex. So something that I had to do was treat complex numbers as contiguous floats. So that's sort of a caveat, something I'd like to sort of, deal with in the future. I know that X-array can be extended. I haven't looked into it very much. Another thing is that this file format supports variable metadata. Like later versions support basically key value data. And I don't handle that as elegantly. I just kind of convert it to a JSON string. That way NetCDF can see a string and encode it, and then everything's works. And then another thing that's a little more open-ended is just trying to discover conventions for HF radar data. It doesn't seem like there's a lot of documentation. I know a lot of people use time series data, they use lat long. Frequency spectra or range dependent data don't seem to be as popular in NetCDF. So I'd love to learn more about conventions in this field so that I could design an X-array format whose NetCDF representation is maximally reusable. But there's only so much time in this week to do that. So yeah, that's the whole package. Was definitely able to get a lot done this week. And yeah, I appreciate the X-array tutorial as well, because that helped a lot getting off the ground.
Brilliant, nicely done, and reuse